All right, let's take a look at some of the problems. I'm not going to do all the problems from the Check Your Understanding, but I want to make sure that we see how the problems that were there tie in with what we spent most of the week doing. So I'm going to look at problem number 3 and 4 because they have some differences in them that we want to pay attention to. So this one, our interpretation of this would have been that I have a base of -5. Okay. It is dark because of this negative here, and there's a stack of 2 of them, right? So if I try to, I'm not going to be able to draw that real well, but I've got the base of -5, and it is mostly dark, and there's 2 of them in the stack, and my natural thing would be I need to make them not dark by moving them into the denominator. So that becomes 1 over the light base of -5 and a stack of 2 of those, which means 1 over -5 times -5, which would be 1 over 25. And this one over here, I've got to consider some order of operations. So this is like there's a -1 out in front, and that was like its own base out there. So we had our card, if we're thinking of this in terms of the cards, we had a -1 that is a base by itself. We had a 4 that was a dark base, and there was a stack of 3 of those. And so we've got the -1. That's not being taken to a power, so it stays in the numerator. These dark 4s are going to become light 4s in the denominator, and a stack of 3 of them. So that means I have -1 divided by 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So this becomes -1 over 64. All right. I'm going to do 10 and 11 as well here. If I look at 5z to the -x, that's a base of a 5. 5 is by itself. The z is being taken to the -x power, so it's a dark z, and there are x of them in the stack. So right away this becomes 5 over z to the x, so I can make a light colored z, a light z base, and it is to the positive x power. If I substitute in my numbers now, it says z is -3, and it is being taken to the second power. That's 5 over -3 times -3 would give me a 5 over 9. On that problem. On problem number 11, sure I'm getting focused here. Problem number 11, the 5 and the z are kind of stuck together here on a card, okay, and it's the inverse of that, and there are x of those cards. So if I'm sliding everything on, the first thing I'm going to do is say this card, I can flip over the things on the card so that I have a positive x power. And so putting my numbers in here, I get 1 over 5 times -3. And then that is raised to the 2 power. So that's 1 over 5 times -3 is -15. So that's -15 times -15 is 1 over 225. Okay, let's look at a few more here. So on this, I'm going to view this, and if I'm thinking in terms of the cards and bases, I've got a base of 2, a base of x, a base of y, a base of z. when the instructions on this were to simplify. So what I'm going to try to do is make sure that I don't have any base showing up more than one location, and none of them have negative exponents. So the 2 here is just a base of 2. It's a light 2 in the numerator. It stays there. My x's, this was 3 dark x bases in the numerator. I can make them into light x bases by moving them into the denominator. With the y, I've got 2 dark y bases in the numerator. I can make those 2 light y bases in the denominator. I have 4 light z bases in the denominator, and they're already light, so I'm going to leave them there. So that's what that answer should be. I guess I didn't circle my other answers up here. I'll take care of that. Okay, on this one, I've got number bases that may have been multiplied together and disguised a little bit, so I'm going to say that what I had up here was a 2 and a 7, and then I've got the 4 dark A's. Kind of trying to make that dark around there, and a stack of 4 of those. And in the denominator, the 20, I'm going to say that I had 2 2's stacked up down there and a 5. That would make 20. 5 times 2 times 2 is 20. And then I had a light B base, and I had 1 dark C base. Scribble that dark around there. So, first thing I'm going to do is move lights and darks around. So that's going to leave me a 2 and a 7 in the numerator. This C is going to come up. I have the C up there. In the denominator, I've got the double 2's, 5, the B is there, and now 4 A's. Right, so that is, canceling wise here, one of these 2's can cancel with one of these 2's. So that will leave me just 1 2 base in the denominator, and what I have left is a 7, a C, a 2 and a 5. 2 times 5 is 10. And a B and an A. I'll write them as an A and a B. Doesn't really matter. That's what that one should simplify to. Okay, on this one, another way to consider this, if I look at the numbers together, it's like I've got a -3 divided by a -6. Right, so I'm ready to start, card-wise here. I've got a -1 and -1. Those would cancel each other out. I've got a 3, and I've got a 3 and a 2. So those would mostly cancel each other out and leave me just with a 1 on the top and a 2 on the bottom. The 3's would cancel out. The H's, let's make sure this is how this was. I've got an H here. This one doesn't even show up on the card. It says I don't have any H's in the denominator, so I don't have to put them there. I do have one H up there. My G was a dark base. I can make it light by moving it to the denominator. My K is a dark base. I can make it light by moving it to the denominator, and so I should have H over 2G squared K squared as an answer to that one. All right, most of the back looks pretty similar. I'm going to grab a couple of problems from the back that are maybe a little bit different looking than what we had before. See if we can get my camera to straighten out here. All right, so this is very different than what we had. This is going to be one base, okay, inside the parentheses. So we've got a one base that is a 3 minus m. We have 4 copies of it, and they're dark. So this immediately becomes 1 over 3 minus m, so we can make them light and keep the 4 copies of them down there. If I now put my 6 in, I'm going to get 1 over 3 minus 6 to the 4th. Order of operations here, 3 minus 6 is negative 3. I have 1 over negative 3 to the 4th, which is 1 over negative 3 times negative 3 times negative 3 times negative 3, which is 1 over 81. Okay, there's a story here on problem number 28. Said a micrometer is an instrument that can measure the thickness of an object very accurately. 1 micrometer is accurate to within 10 to the negative 4 inches. Evaluate this expression. So 10 to the negative 4 inches, give us some units on there. Well, that's a base 10 that's dark, so we can make it light by making 1 over 10 to the positive 4, which is 1 over 10 times 10 times 10 times 10, which the way multiplying by 10s work, 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros, so that is 1 over 10,000. Okay, I think the rest of what you see in there is pretty straightforward, so I'm not going to do a bunch of the other problems and try to keep the length of this video down a little bit.